Hello gang, here to go over the quiz with you from last week for graphing quiz 1. So let's dive in and see how to solve these problems. So the first one was to describe the motion of the object represented by the velocity versus time graph below. Utilize the term speed, direction, and displacement. So it's a little vague in the instructions, but it kind of on purpose wanted to see how you were going to describe this thing. So some of you I noticed label the axes, which is totally fine. You can label the axes by 1, 2, 3, 4, 5, 6 here, 7 seconds. Didn't have to though, it's okay if you didn't. But what I was looking for here was the fact that this object starts off with positive constant velocity. So you might say the object has constant positive velocity initially, right? You didn't have to tell me it was for 3 seconds or something like that, although it was for 3 seconds, if that's how you labeled the scale here on your graph. But I wanted to hear the words constant and the word positive and then the word speed or velocity. Constant speed velocity initially. And then what happens here? Well, it all just bam, instantly what happens? The object turns around. Object turns around, right? Like on a dime, right? Just bam, instantly. What happens to velocity now? Now velocity is constant and negative. That's -1 here, okay, if you were going by ones on the scale. So the object turns around and then has a constant negative velocity. My handwriting is so good, I know. Please don't ever comment on how good it is. Turns around and has constant negative velocity, okay. For the remainder of the, for the remainder of the graph, or however you want to say it. And then I want to hear the word displacement. So what was my total displacement? Was my total displacement positive or is my displacement negative? So no matter how no matter what scales you use on these graphs here, let's switch to a different color. I'll go yellow. If you shade in the region here, which under the x-axis for the positive region of velocity and then the negative region of velocity, you can clearly see that the positive region has a larger area than the negative region, right? Because we're going faster for positive velocity than we were for negative velocity. So my displacement is positive. Now you could have said that the displacement was, if you do by every square is 1, right? So 1, 2, 3, 1, 2, 3. Then this is 9, and this is 4. So displacement would be +5. But all I really wanted to get credit here was displacement is positive. You didn't have to give me a number. If you did, it's totally okay, but you didn't have to. So basically 1 point for telling me constant positive velocity here, 1 point for telling me it turns around and it has constant negative velocity, and then 1 point for displacement is positive. And if you are more detailed, awesome, but you didn't have to be more detailed. So that's 3 points for number 1. All right, let's go to part B, number 1 now. Part B, number 1 talks about it gives us these two graphs here. We have object A and object B, and it's asking us to, on the graph provided, to draw and label quantitative, it's important, quantitative velocity time graphs for objects A and B. So we always want to make our graphs sluts. All right, sluts. The slut is for scale. The L is for label the axes. U is for units. Oh, I just wrote untis. I don't know what that is. Sorry. Units. T is for title. And then the second T here is for a trend line, although we don't really need we're going to draw the trend line here. That is the graph, the trend line, right? Trend line mostly, if you have like a curved graph, goes up, you want to draw the trend. But on a linear line, it's pretty easy because it's going to be a straight line anyway. All right, so let's take a look-see here. Get rid of this cursor. Don't do that. All right, so object A. Well, first we got to label this graph. We're going to make a velocity time graph. This is V versus T. That's really all you need to do. That's totally fine. It's a velocity versus time graph. I have velocity on this axis. It has going to be measured in meters per second. I put that in parentheses. I put time down here, measured in seconds. I've now taken care of my L, my U, and my title. I just got to write a scale now. So what do I want my scale to be? Let's see what the values are going to be here, and then we'll figure out the scale. This is a position time graph. So I know that my slope is velocity. So one of these guys has a positive slope, one of these guys has a negative slope. So this guy has a constant positive slope. What's my slope? Well, let's see. It goes up 2 over 2. Up 2 over, ooh, just a little bit more than 2. It's like just more than 2, like 2 point something. I don't know. So if maybe I go by ones. This is 1, this is 2, this is 3. So it's up 2 over 2. So that's 1. Sorry, not 2. My bad, guys. Rise of 2 over a run of 2 would be 1, right? So my apologies. Slope is about 1 or just over 1. It's like maybe 1.1 or something. Because see here, it goes to like 4 point something and then 4. And then here we're at 6, almost 7 there. So, you know, I guess if we wanted to go all the way to the end, it says 9 over 8. So a total rise of 9 over a run of 8, changing y or changing x. So 9 over 8 is going to be, what's that, 1.1-ish? I don't know. I can't do math in my head. Let's figure out what the calculator says. 9 over 8 is 1.125. So let's call it 1.1. All right. Positive 1.1. And then this guy, this slope here, he starts at positive 6 and ends at a negative 8. All right, so change in y, so slope is change in y over change in x axes, right? So my y2 value is a negative 8 minus a positive 6 over my change in x is a 10 minus 0. So this is a negative 14 over 10. So that's a negative 1.4. That's a 4. I can't. I'm running out of room here. Let me erase a little bit and make that better. I'll start this. I started it too far to the right. Let me start it over there. You guys get the idea, though, I think. So my slope here is going to be negative 1.4 because it was negative 10 minus. Negative. Gosh dog it. Gosh dog nabbit. Sorry. Hopefully you're following me here. I don't feel like making 18 videos for this. So okay, my final y value is negative 8 minus my initial y value is positive 6, and then 10 minus 0. So that is negative 14 over 10, and that equals negative 1.4. All right. So the slope of this guy, my velocity is negative 1.4. And my velocity of this guy's about 1.1. All right, so I go to my position time graph now, and I think I could have even made this like half and then 1. Maybe that's better. Maybe I should do that, right? Once I know what my velocities are, I can then make a better scale, right? I want to use up as much of the graph as possible. I don't want to leave a bunch of empty space. So I'm gonna call this 0.5 here, and 1.0 and 1.5 at the top. It's negative 0.5, negative 1.0, and negative 1.5 here. All right, so my positive velocity is 1.1. Now the slope is constant, so the velocity is constant. So it's just going to be about 1.1 in here, and I'm going to try to draw a straight line, but I probably will fail. But it should be a flat line, right? A horizontal line all the way until 8 seconds. So where's 8 seconds? Well, it looks. My max is 10 seconds. So I think I'm going to label these 2 each. So this is going to be 2 seconds, 4 seconds, 6, 8. 10. So this object A only goes to 8 seconds, you'll notice. So I do not want to go all the way to the end. If you went all the way to the end, I might have to take off a point for that. Let's just stop here at 8. So this is object A. And then on the object B, I'll do that in a different color just to be crystal clear. Do that in blue. So this is negative 1.4. So all the way down here. So right about here. And again, I'm going to try to draw it straight as I can, but forgive me if I don't draw it perfectly straight. Pretty good. Okay, all the way to 10. This one does go to 10 seconds, right? You see here, this does go to 10, but this one only went to 8 seconds. So I don't want to draw this all the way to 10. It didn't last that long. It stopped at 8 seconds. So here's object B. Make sure you label those, and now I have a scale. So I got my scale in there. The trend line is, the actual line, right? So I don't really need to include that on this because it's just a flat line anyway. But there we go. So we have 1 point for getting all these things. 1 point there, 1 point for this graph, 1 point for this graph, and then 1 point for, well, maybe it's be 2 points. I don't know. I gotta get a 4th point in there somewhere because this one's gonna be worth 4 points. So maybe 2 points for all this stuff, and 1 point for each graph. So we'll see how that goes, but 4 points total for that. All right, so that's part B. Let's go to number 2 now. So number 2. Shown below. Let's go back to my purple. I like the purple. I like it. Fuchsia, whatever it is. Okay. Shown below is a velocity versus time graph for an object Part A, draw. There's only one part. I don't know why I have part A. It's only one part. Draw the corresponding position versus time graph. Number both axes. All right. So in other words, we need scale, right? So we need to make a graph of slut. Scale, label the axes. Our axes are already labeled for us, so yeah, that's nice. Units already have. I know it's like an N, but it's supposed to be a U. Already have the units on there, meters and seconds. So that's cool. Already have that done. Need to have a title. This is a position versus T, and then I have my scale. So that's what it means by number of the axes, right? I put a scale on there. So let's make sure we do that. But first, let's figure out what my velocities are. All right. So my velocity is a positive 4. For the first 2 seconds, right? So I'm gonna go ahead and, oh my gosh, that's a bad line. I could do better than that. For the first 2 seconds, see how it goes to 2, right? So I'm gonna go and shade this area in just while I'm at it, just because we're gonna do that in a second anyway. So now remember, if this velocity is a positive constant 4 for the first 2 seconds, then I need to have a slope here of positive 4 for 2 seconds. So that means I'm gonna have this go to, I'm gonna say 5, and the top is gonna be 10. I'm going to have a little line that's, so it's 6, 7, 8, 9, and I'm going to have this is 0, and it's going to be 1, 2, 3, 4. I'm not spacing these out very well, but you get the idea. Try to do as neat as possible. Now this time goes to 5 seconds here, right? So on my time scale on my x-axis here, I'm going to have to go to 5 also. So it's 1, 2, 3, 4, and 5, and I'll label that real quick. 1, 2, 3, 4, and 5. Okay. So for 2 seconds, I'm going to go have a slope of 4. So my slope goes up 4 over 1. Put a little dot there. Up 4. Say 1, 2, 3, 4, about there. And then put a dot. So that should be 8, right? Yeah. And I'm going to draw the line, connect these like that. All right, good. And then what happens to my velocity? Well, then, boom, I go all the way down here to -3 velocity for 1 second. Let's go ahead and color that area under the curve in as well. So now I go, if my velocity is -3 on my velocity time graph, that means my slope on my position time graph is -3. So I need to go down for 1 second. I'm going down 3. So I go from 8, 7, 6 to 5. So at 3 seconds, I'm going to be at the 5 mark here, right there. And then for the last 2 seconds, what's my velocity? Well, it's 0, right? It's on the x-axis. There is no velocity. So how do you draw that on the position time graph? It's a flat line, right? Just flat like this, just flat, right? And there you go. So your graph should look like this, hopefully a little neater, but more or less like that. Bonus, what is the final change in position, or otherwise known as displacement? Well, 2 ways to find this, guys. Look at the graph. We went up to 8, but back down to 5. Remember what displacement means. It's how far from the very final position, the starting position to the final position. Well, let's circle those real quick. Let's do different colors so we can be clear. Go orange. So we have our starting position and our final position. Well, our starting position was 0, and our final position looks like 5. So my displacement was 5 meters. Now another way to do this is look at the area under the curve, because we know, you all are going to remember this forever, or at least till May, that the area under the curve of a velocity time graph is displacement. What's the area under this curve? This is a 2 by 4 rectangle, so the area here is 8. But we also have this, don't forget this rectangle also, right? This area here is a -3 by 1 rectangle, so it's a -3. Hope you see the negative sign in there. So 8 minus 3 is 5. So no matter how you do it, you get the right answer. So this is, well, by the way, this will be worth 3 points also. So it's be also worth 3 points. 3 points for this one. Again, and it's bonus is plus a point, so you can get 11 out of 10 if you got the bonus and you got everything else right. So 1 point for the graph being correct, 1 point for getting the scale right, and then another point for going to the right, what kind of shape of the graph being correct. So qualitative a point if you get the right shape, and I'll give you an additional point if the numbers are all correct. Because I saw a lot of students who drew the right shape, but they didn't quite go to the right number. So that's how that's going to work. So 3 here. 4 for number part B and 1, and then 3 more points, number 1 part A. So it's 10 total points. Hope you guys did well. If not, well, now hopefully this helped you kind of understand what you did wrong. So I'll see you guys next week. Have a great weekend. Remember, if you have any questions over this quiz or anything else in class ever, send me a message on Remind or email me because, right, I have no life. You are my life. So I'll see you next time. Bye, guys.